Welcome to the Walton Pi. Today we're going to be going through a couple examples of word problems that you might see on a calculus test. If you haven't already, please subscribe and like this video because it really does help me to be able to continue to make these. So, without further ado, let's get started. Alright, let's do some word problems. So, let's suppose that you were writing an English paper and got really bored, because we all know that we much prefer doing math homework to writing English papers. And let's say that you were deciding to practice your math while you were delaying working on your English paper, and you decided to figure out how many words do I fit on an average line. And you found that the number of words that fit in one line when in your English paper follows W of x, where W represents the number of words, is equal to 10 times 1/2 plus e to the 2 minus x over 12. Because we all know that is something that we easily find when we are measuring the number of words per line, where x is the font size, and we also found that the height of one line in pixels was 8 plus 2x, where again x is representing the font size. So we know that our average paragraph in our paper, 90 words, let's find two things. So first, the height of the paragraph when the font is 24 point, and B, the rate that the height of an average paragraph is increasing per day if we are increasing the font size by 3 points per day to try and get the paper long enough to turn in, because it's much easier to just increase the font size than to actually write more words. So let's go through and figure out these two different things. So the first one is, what's the height of the paragraph when the font is 24 points? Well, what does this mean? Well, we know that the entire paragraph has 90 words, but not all of those words are going to fit in one line. So first, we're going to need to know what's the number of lines, and then second, we need to know how tall are each of those lines. So what we can do is we can find an equation that says the height of the paragraph, so h of x, where this is the height of the entire paragraph, this is equal to the number of lines, so let's say that that is L, so this is the number of lines, times the height of one line, h of x. So we need to figure out how many lines are there going to be in a paragraph. Well, we know that we can fit a certain number of words per line, and then that's going to be able to get us to how many lines there's going to be. So the number of lines is going to be 90 divided by how many words we can fit in one line. So that's 90 divided by W of x. So that means that our entire height function is going to be 90 times our height divided by the number of words we can fit per line. And this is going to give us the height of the paragraph. So when the height is, or when the font is 24, we need to figure out what's the height. So h of 24, well, that's going to be 90 times little h of 24 divided by the width, or the number of words when there are 24 point font. Well, height of 24, we can come over here and say, well, height of 24, that's going to be 8 plus 2 times 24, that's 8 plus 48, so that's 56. This is 90 times 56 divided by the number of words when there are 24 point font. And when we plug 24 into the width, we get 10 times 1/2 plus e to the 2 minus 2. So that's 10 times 1/2 plus 1. So that's 10 times 1.5, so that's 15. Well, 90 over 15, those divide nicely. So that means that the top is a 6, so the height at 24 is 6 times 56, or 336 pixels. So that is how tall this paragraph is going to be. So the height of the paragraph when the font is 24 point, that is 336 pixels. Let's now do part B. Well, we need to figure out what's the rate that the height of a paragraph is increasing. So that means we need to know what's the derivative of our height function of the paragraph. So we need to find what is h prime of x. Well, h prime of x, this is going to be a quotient rule problem. So we have low d high, so that'll be a w of x times the derivative of the top, so 90 times h prime of x, minus high 90 times h of x times the derivative of the bottom, w prime of x, all over w of x squared. And now we can plug these different pieces in. We know what w of x is, we know what h of x is, so what's h prime? Well, h prime of x, that's going to just be 2. The derivative of h plus 2x, that's 2. Now, what's the derivative of the width function? This is going to be a little bit trickier. Well, the derivative of this, first we might want to break up the width function into a couple pieces. We might want to say, here, let's get ourselves a little bit of room. So we got width of x, that is, let's multiply the 10 all the way through. So that's going to be a 5 plus 10e to the 2 minus x over 12. Now if we need to take the derivative of that, w prime of x, well, the derivative of 5, that's 0, but then the derivative of 10e to the stuff, well, this is where we're going to need to use the chain rule. So that's going to be 10e to the stuff multiplied by the derivative of that stuff. Well, derivative of 2 minus x over 12, well, that's a negative 1 over 12. So w prime of x is negative 10 over 12 e to the 2 minus x over 12. And this is what we're going to plug in where we have our w prime of x. So let's move this out of our way a little bit. So now we can plug in all the different pieces we know. So we know that h prime of x is going to be our width, 5 plus 10 e to the 2 minus x over 12 times 90 times h prime was 2 minus 90 h of x, 8 plus 2x, times our derivative of our width. Well, that's this entire piece. So negative 10 over 12, so that's a plus, times, we got 10 over 12e to the 2 minus x over 12, all over w of x squared, all over 5 plus 10 e to the 2 minus x over 12 squared. Now, we don't need to simplify this, we just need to know what is this when x is 24. Because that is what we are increasing at a specific time. We are increasing the font size 3 points per day. Now, each of these has a dx dt in it, because this 3 points per day, that's telling us how fast is x increasing. So, if we were to fix those pieces in here, we'd have h prime of x dx dt right there, and a dx dt right here. So the entire thing has a dx dt at the end, so let's just stick that right here. So, going through and plugging in the different values we get, we find that h prime at 24 is going to be, we got 5 plus 10 e to the 0, so that's a 15, times 180, 9 times 2 is 180, plus 90 times 8 plus 2x, let's see, 8 plus 2x, 8 plus 48, that's 56, times 10 over 12 times e to the 0, that's times a 1, all over, let's see, 5 plus 10 e to the 0, that's all over 15 squared, multiplied by dx dt. Well, dx dt is 3, and so now we just have to simplify whatever this is. So, going through and simplifying a little bit more, we find that, let's see, 15 times 180, I feel like there's a lot of 15s that we can be able to cancel. So let's look at 10 over 12 first. So 10 over 12, that's the same thing as 5 over 6. So that is the same as 5 over 6. So 90 divided by 6, that's 15. So we have a 15 there. And then what we have left on the top is we have a 15, 15 over 15. So that means a 15 will cancel from everything. And then we have 180 plus 15 times 56. over 15. So let's write that down. 180 plus 15 times 56 over 15. Well, 180, that's divisible by 15, so we can rewrite 180. Let's see, 15 times 2 is 30, and then 30 times 6 is 180. So 180 over 15, that's 15 times 12. So we have 15 times 12. All of those 15s now cancel. Oh, we forgot to distribute the 3 onto this one. So there's a 3 times this one as well. So that's 36 plus 56. So that is 80 plus 12, so that's 92. So it is increasing 92 pixels per day. That is how fast the height of the paragraph is increasing per day if we are increasing the font size 3 pixels per day, or 3 point per day. Now this makes sense, because if we increase the font size by 3 points per day, that means that our height per line is increasing by 6, and then the number of lines, well, we found that at 24, there were going to be, let's see, 90 divided by 15, so there's about 6 lines, and all of this is making sense. This is about the number that we would expect. So let's now do the second problem that I have prepared. So we have a problem involving Charlie Bucket. So, Charlie Bucket is making rock candy by leaving a string inside water with a lot of sugar dissolved inside of it. Every day, about 16 grams of sugar is crystallizing onto the string. But Charlie, with a little bit of help from Wonka, has decided to get the candy to crystallize into a perfect rectangular prism where the height is always 5 centimeters and the length and width always form a square. So if Charlie started making this candy at the beginning of Monday, how fast is the width of the candy increasing at the very end of Thursday? And if you need it, the density of sugar is 1.6 grams per cubic centimeter. Let's go through and try and figure this out. And yes, I do just realize that this needs an n in there. So it's okay. It's per cubic centimeter, whatever that is, but it's supposed to be centimeter. So let's go through and try and figure out how we would do this. Go ahead, pause the video, and try it on your own first. Alright, the first way that I would do this is I would start to draw a picture of what we are trying to do. So we have a candy that is crystallizing in a perfect rectangular prism where the height is always 5 centimeters and the length and width always form a square. So that gives us quite a bit of information to be able to start to draw a picture. So we know that it's going to be something like this, where the height is always 5, and we know that the base is always the same, so x and x. So what we can then do is we can try and figure out how can we use this to help us figure out some of this problem. Well, we are trying to figure out what are the different things that are connected to this. Well, one of those is the fact that we have 16 grams of sugar is crystallizing onto the string every day. So this actually tells us what's the rate that the volume is changing. It's changing at a positive 16 grams. Are grams a unit of volume? No, like grams are a unit of mass, so we need to figure out what's the volume. Well, that's what this density piece down here at the end is telling us. The density is 1.6 grams per cubic centimeter, so that means this is actually, change in volume is 1.6 grams divided by 1.6 grams per cubic centimeter to give us 10 cubic centimeters. So that's how fast it is changing. It's 10 cubic centimeters per day. So let's try and connect this to what we know. Because we know that this is going to be a representation of the volume. So we know that the volume of the sugar is going to be 5 times x times x. So the volume is 5x squared. But what are we trying to find? We're not trying to find the volume at the end of Thursday, because that would just be how many cubic centimeters were we adding, and then how many days did we add it. No, we're trying to find this. We're trying to find how fast is the width of the candy increasing at the end of Thursday. So the width That's this thing down here. That's the x that we're trying to find. So we need to find what is dx dt. That's what we don't know. So let's go through and try and figure that out. Well, volume is 5x squared, so if we just take the derivative of everything with respect to t, we get that dv dt is equal to 10x times dx dt. Well, dv dt, that's 10, so we can plug in the things we know. So we get 10 equals 10x dx dt. So dx dt is equal to 1 over x. Well, that was a nice number. That's a nice thing to be able to find. But the challenge with that is, what's x? What is x at the end of Thursday? Well, that's where we come back to our volume equation. We know how many days it's been growing. It grew on Monday, Tuesday, Wednesday, and Thursday. So that's 4 days. So that means we know that the volume is 4 times the number of cubic centimeters it gains per day. So that's going to be 40. So 40 is 5x squared. Divide 40 by 5, and we get 8. We get 8 equals x squared. So x is the square root of 8, which is 2 times the square root of 2. We can take that and put it into this to find that dx dt is going to be 1 over the square root of 8. And what is this? This is centimeters per day. So there we go. We were able to solve this problem. Even though they didn't give us a picture, they just gave us this big word problem, we were able to go through and figure it out by ourselves. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.